Hey guys, here's a video to help with some of the volume problems that we talked about today. I'll do a couple of the basics here, and if you need any additional help beyond that, just let me know. So let's just take a look at, let's look at number 2 here. And we know that volume is big B times H, where big B is the area of the base, and H, of course, is the height of the prism itself. So in this kind of, when you have a rectangular prism, you kind of have your options of what you want to be your big B, what you want to be the base that you're looking at. I guess instinctively it seems like we want the bottom to be the base, right? Because you'd have a top here that matches perfectly, parallel and congruent. But it wouldn't be wrong to use the, sort of the front and the back if you want. And then, of course, you could use the left and the right here. It really only gets tricky when you have those triangular ones or trapezoidal ones or anything fancy like that. So for this one, I'm just going to go ahead and use the bottom. So my big, my big B would be 5 times 6. That's the area of the base of the prism itself times the height of the prism. The height, remember, connects the two bases, so it would be 8 here. If you chose to use the front and back, your height would have been 6. If you chose to use the left and right, your height would have been 5. It's just a matter of how you want to view your prism. So this, of course, would be 30 times 8, which would be 240 cubic units, or they didn't give us anything specific, so we could just call it cubic units. Okay, and that's about as basic as those kind will get. All right, let's try one a little more variety here. We have a triangular prism here. Okay, so again, the volume is not going to change. The formula is not going to change. The question is, what's your big B? We talked about this in the other video when we did surface area. It's the same kind of idea. You're still looking for big B. And if your instinct is to have the bottom be your big B, unfortunately that's not going to work because there's no top that matches. There's no top that's parallel and congruent to this. You can't use left and right because, again, those aren't parallel. They actually connect here. The only thing that would make sense is to use the front, which is here. A little hard to see there. You got the front and then, of course, the back. So I'm going to use the front as my big B. And the area of my big B here is the area of a triangle. The area of a triangle is 1/2 the base of the triangle, not to be confused with big B, which is the area of the base of the prism. But 1/2 the base of the triangle times the height of the triangle. And that's your big B. 1/2 4 times 10. 1/2 the base of the triangle times the height of the triangle. That's your big B. That's the area of the base. Times the height of the prism. Again, the height of the prism is the value, the length that connects the two bases. So I know it's weird to have the height kind of go, almost sideways here, but that's the height. Okay, it doesn't, you could imagine this triangular prism on its front, and you could see that it would be 2, centimeters high. Imagine this part came forward and fell down. Then this would look like the height that you want it to be. But it's still considered the height because it's what's connecting the bases. All right, so this would be 1/2 of 40, which is 20 times 2, which is 40. All right, the 2 and the half end up canceling, so you still end up with 40. In this case, it's cubic centimeters. All right, let's try to find another one. Let's do a cylinder. Okay, doesn't really matter. They're all kind of the same. Let's do one. Let's do 14 here. Okay, so I'm going to write this every single time because in my mind that's just how I remember it. But on your formula sheet, you'll see that it already takes care of big B, because big B is always a circle for a cylinder. No matter if it's, this way or this way, the cylinder is always going to have the circles as the bases. That's just sort of how a cylinder is made. So I could really just write pi r squared times h, and that'll get me the same thing. So it's still big B, but big B is a circle. In this case, they give us the diameter as 13. So if the diameter is 13, that means the radius is 6.5. So pi r squared times the height of the cylinder, which is 15. And at this point, I'm going to need a calculator to help me out. I could probably approximate it. I don't know, this has got to be 6, 7, 42 and a quarter, 400, 600, 1800 maybe? Let's see. Pi 6.5 squared times 15, 1990. I have no idea what I said before, but I don't think that was right. So it doesn't matter. Use the calculator. So 1990.98, and that's going to be cubic inches. Let's see, how did we round it on the answer key? Just curious. 1990 What did we put here? Oh, okay. So they must use the pi button on the answer key too. So we're good. Okay. Had you done it using 3.14, just for the fun of it, let's see. So 3.14 times the radius squared times 15. You would have gotten 1989.975. Pretty good, actually. Still pretty close. But if you got that and you checked the answer key, don't worry. You did it just fine. Okay. Hopefully that helps. If you need any additional support, just let me know. And I'll talk to you guys later. See ya.